In this section, we're going to look at adding and subtracting rational expressions, and we're going to do that when the denominators are the same and when the denominators are different. And in the case when the denominators are different, we're going to have to find a least common denominator. And let's just start off as a refresher here to add two fractions that are not, that don't involve algebraic expressions. When you're adding fractions and the denominators are the same, you just add the numerators and you keep the denominator the same. So the answer to that is just 4/7. So we do the same with algebraic expressions here, or rational expressions with algebraic expressions in them. And here we have a common denominator. It's 7x plus 3. So all we need to do is to combine or add the numerators and just keep the denominator the same. And here we're going to combine like terms. So we're going to have 3x plus 1 over 7x plus 3. And in any of these problems, in your final answer, you want to double check and make sure that there are no common factors, see if you can factor anything. And these polynomials are factored. There's nothing we can do. Remember that plus sign, it almost acts like a, like a chain where these are linked together. With these two, the only way you can cancel them is if you see another 3x plus 1. And these are also, if you want to say, kind of stuck together. You cannot cancel them because they're not, you can't cancel individual parts because they're not factors. And so this would be your final answer. Now let's look at a subtraction problem. Now in this case, we're going to do the same. We've got a common denominator. And so what I need to do is subtract the numerators. So I've got 5x plus 1 minus, but I need to put that in parentheses. Right? I'm subtracting. The denominator stays the same. Now when you subtract polynomials, remember it's like distributing a -1. And so you're really going to just change the sign of every polynomial, of every term inside. So we're going to get 5x plus 1 minus 4x plus 6 all over x squared minus 25. And then we're going to combine like terms. So we end up with x plus 7 all over x squared minus 25. And so in this case, I would, I'd try to factor the denominator to make sure there were no common factors, and you can do that right underneath if you want. X squared minus 25 is x minus 5 times x plus 5. And so there's no common factor there, and so you can leave your answer as is, and I'll just erase this. And so this is your final answer right here, x plus 7 over x squared minus 25. All right, at this point, I'd like you to, pause the video and try the next two problems and see how you do. And then, start up the video again and see the solutions done out. If you don't feel confident enough to try one at this point, you can certainly just watch the video and take notes on these. Okay, for the first one, I already have a common denominator. So I'm just going to add the numerators. Again, a lot of you can just look at that and get your answer by adding in your head. You're going to get 2x plus 8 over x plus 4. And now I'm going to factor the numerator just to make sure that there are no common factors that I can cancel. If I take out a 2, I get x plus 4. And so I can cancel the x plus 4 factors, and now my answer is just 2. Right, this one is a little bit more complicated, and since we're going to subtract the second polynomial from the first, another suggestion I might make is that instead of rewriting this, with a minus sign and a set of parentheses, we know we have to add the opposite. And so what I'm going to do is I'm going to write the first numerator. Let's just focus on the numerators for a second. I'm going to have 20y squared plus 5y plus 1. Instead of writing subtract in parentheses, I'm just going to change the sign of every term in that next polynomial. So if I was subtracting a positive, I'm really adding a negative. So the 8y squared is negative, the 12y is going to be positive, and the 5 will be positive. So I'm adding the opposite of every term in the second polynomial, which is the equivalent of distributing that negative onto each term. And before I even write, since I didn't say this was equal to this, I'm just going to combine the like terms and get my numerator squared away, and then I'll add the denominator in. So I have 12y squared plus 17y plus 6 all over that denominator of 6y squared plus y minus 2. Now I can see here I've got true trinomials. I'm not sure if they're both factorable, but I'm going to try and factor them. And so the numerator is 12 and 1 and 6 and 1, or 12 and 1 and 2 and 3. I'm going to look at those to see those combinations first to see if I can get a sum of 17, and it doesn't look like that's going to happen, so I'll try 4 and 3 and 6 and 1 and 4 and 3 and 2 and 3 and see if I can look and see if the products will equal 17. So I can see it right here. I'm going to have 8 and 9. When I add those together, I get 17. So I'm going to circle diagonally. So my numerator, I'm going to get 4y plus 3 times 3y plus 2. Now let's work on the denominator. I'm going to try 6 and 1 and 2 and 1 and 2 and 3 and 2 and 1. And this time I'm looking for the difference to equal 1. And it looks like I have it here. If I arrow across, I get 4 and 3. Their difference is 1. So I'm going to circle diagonally. So I know I'm going to have 2y and a 1 and a 3y and a 2. Now the larger product has to be positive. It's got to match. So the 2 has to be positive. That has to be negative. So now that I've got these factored, so my final answer is 4y plus 3 over 2y minus 1. All right, so in the next video, we're going to look at adding and subtracting rational expressions that have unlike denominators. And so we're going to have to look at how do we find the LCD and how do we build fractions to have that LCD.